Good evening to all in Korea. It's the evening here. And good morning to those who are viewing this in Germany. My name is Ryan Song from Kyung University. I'll be facilitating this event or pre-event. It is my great pleasure to welcome you all to the 6th Leopoldina KAST Bilateral Symposium pre-event under the theme of Realizing the Promises of Artificial Intelligence. And I should also welcome those who are connecting through YouTube. This is your chance to ask questions. We have exciting talks from two experts and great minds in the artificial intelligence area. So if you leave questions, I'll try to get to as many as possible to make this event more meaningful. Now, before we get started, I'm delighted to invite or welcome Professor Min-Koo, the president of KAST, and also Professor Haug from the Leopoldina. He's the president of Leopoldina, to give us some welcoming remarks. President Han, you go first.
Good morning to the participant in Germany and good afternoon to the Korean participant. It's my great pleasure to greet all of you on behalf of Korean Academy of Science and Technology. Above all, I would like to express my sincere gratitude to Professor Gerald Haug, the president of Leopoldina, for hosting this joint event with us. I deeply appreciate Leopoldina's great cooperation for both countries' scientific prosperity. I also send my sincere gratitude to the world-renowned experts, Professor Alexander Waibel and Professor Alice Oh, who are joining us to share their abundant expertise in AI, and to Professor Ryan Song to share his great insight on the social responsibility of AI. Today's event is a pre-event of 6th KAST Leopoldina Bilateral Symposium in September 22 on the theme of artificial intelligence and the digital age, which will be held in the celebration of the 10th year cooperation between KAST and the Leopoldina. AI has a great potential to change our daily life and our society. Like all powerful new technologies, great care must be taken in its development and deployment to reap the social benefit. I hope this talk will be a great opportunity for us and to realize promises of artificial intelligence. Thank you.
Thank you. Next, Professor Haug, please give us your welcoming remark.
Dear President Min-Koo, dear colleagues and participants, it is my honor to welcome you on behalf of the German National Academy of Sciences, Leopoldina. KAST and Leopoldina are strategic partners for almost 10 years now. Together, we are strongly committed to promoting excellence, science, and international cooperation. Together, we address scientific breakthroughs and cutting-edge technologies to maximize their positive impacts on people and on the planet. Artificial intelligence is a truly transformative technology, and it is advancing with great pace. Artificial intelligence can help analyze enormous volumes of data. It helps us cure diseases and improve healthcare. Artificial intelligence has started to change our jobs and workplaces and how we communicate with each other. Artificial intelligence can help fight climate change, boost economic development, and benefit our daily lives in many ways. However, there are also serious challenges and ethical issues at stake. There are concerns about cybersecurity, human rights, and privacy. I'm grateful to two leading experts, Professor Alice Oh and Professor Alexander Waibel, have agreed to share their insights and how to harness the promises of artificial intelligence and address the challenges for science and society. I look forward to your innovative ideas on how we can work together to develop the framework that enable responsible innovation and benefits for all. And I look forward to continuing the discussion on artificial intelligent research at the next KAST Leopoldina Symposium in Seoul in 2022, in person and in good health. Thank you.
Thank you, both presidents, for your welcoming remarks. So this is the time to introduce to you the stars of this event. I'd like to introduce to you first Professor Alexander Waibel. He's a professor at Carnegie Mellon University and Karlsruhe Institute of Technology, and he's the inventor of the first speech dialogue translation and simultaneous interpreting systems. He's joining us from Seattle. Hello. Professor Waibel?
Hello, good to be with you.
Thank you. Now, I'd like to introduce to you the panelists from the Korean side. Sitting right next to me, Professor Alice Oh. She is a professor at KAIST and the director of KAIST Institute for AI. Hello, Professor Oh.
Hi, it's nice to be here.
Thank you. Now, let's have an exciting presentation first. We'll have a discussion afterwards, but would like to hear from Professor Waibel and also Professor O to give us the experts' point of view and insights on AI. Let's have Professor Waibel go first, please.
Thank you so much for having me. It's a privilege and a pleasure. Hopefully next year we will get together in person. It is wonderful always to come to Asia and to explore our friendship between the cultures and the countries. And I always enjoy coming to Korea. And so we look very much forward to the event next year when we can finally and hopefully overcome this terrible pandemic and share with each other in person. Now, in anticipation of this, I'm giving to you here a short presentation over the core topic that will concern us this time as well as next time, which is artificial intelligence. A lot has been said and written about AI and what it means for society. There's scary things and wonderful promises. And so my talk will be a little bit of a basic introduction as well as a vision for the future and a little bit also about our own research. As was said, I am a professor at Karlsruhe Institute of Technology and also at Carnegie Mellon Universities, two universities that are centrally engaged in artificial intelligence research. So we're keenly aware of some of those worries that concern us together. Now, to begin with, it's important to note what a dramatic revolution AI has been. As you can see here, we have the market capitalizations of some of the largest firms in the United States between 2006 and 2016, where a complete reversal of large corporations has happened, where the biggest companies were before oil companies and major industrial companies, and now they're all exclusively companies that consider themselves nowadays AI companies. You see that by the quotes here on the right, that the leaders and the presidents or CEOs of these companies really concern and consider AI as one of their central technologies and their central core concern in terms of being profitable for the future. So AI really represents a multi-trillion-dollar shift in wealth and a total reversal of where the focus of growth and the focus of innovation happens today. Now, how could this happen so quickly and what really happened in between? AI is not really new. It started in the 50s with the famous Dartmouth conference when some of the scientists really charted this particular interesting field of building intelligent systems or computer systems. Now, there were many booms and busts. This has also always not gone well, and many of the early technologies really didn't deliver on the promises. And it hasn't really been only recently that AI has become such a powerful force. Now, why is this so? It's largely due to the arrival of neural networks, which are now called deep learning. And AI currently is synonymous really with neural network technologies. But even those were not really new because they were in fact explored in the 1980s with great vigor already. And they represented an interesting alternative to the traditional techniques that were done before. Now, neural networks are trained networks, as you see here in the pictures, that try to mimic some of the processing that goes on in the brain. And one of the most interesting aspects of that, for me at least, when I was an early researcher on this, was that they can in fact build internal representations automatically without us having to specifically specify what these internal representations need to do. And that is, of course, super exciting because what that means is we can create tasks for these systems and have them internally or self-organize and organize their own representations of the world around them. In the 1980s, we then realized that we needed certain modeling variations and needed to develop extensions to make them useful for practical problems such as speech and vision. And we came up with an architecture. This is myself and Jeff Hinton and some colleagues, where we developed a so-called time delay neural network, which would have the aspect of having context at each layer and to do shift invariant classification, a key aspect of neural networks to make sure that they work on practical signals in practical applications. The time delay neural network was very successful. It performed rather well. And today it's called convolutional neural networks, as these were the baseline or the base innovations to create shift invariant classifiers. Now, we had early models, as you can see in these pictures, where
MEYER.
speech recognition in the 90s were already used in our laboratory for speech recognition and handwriting recognition with great success. The vision community took up on that and built models that they then called convolutional networks. Now, this is in the 1980s. How come we didn't have the revolution then? Well, it was an alternative that did actually perform rather well, but the performance improvements with neural networks in the 80s were rather modest. And the reason for that was that statistical learning and statistical learning methods performed actually rather well in comparison with neural networks and were much simpler to implement with the limited data and the limited computing powers in the 80s. Now, with that, neural networks were largely ignored in the 90s, all the way to 2010, when with the arrival of more data, massively more data, and massively more computing, this difference between neural network deep learning methods and other learning methods started to diverge. Computing really doubled and tripled and multiplied as Moore's law continued to deliver great performance improvements of computing. We see that here, that even in my lifetime, there is a trillion-fold acceleration in computing, or billion-fold during my career. And this massive improvement in computing technology really drove and drives still today this possibility in algorithmic advances. So from 1990, when the performance was rather comparable, we now see an enormous gain or enormous difference with a surprising improvement over traditional statistical methods. Now, with 30% gains over traditional method, neural methods really took the community by storm and branched out into every field and took over pretty much everything. Now, here you see a graph. It's a little confusing, but please just pay attention to the right lower end, where in fact, on a very common and popular task that we started with in the 1990s, speech recognition really came of age. Conversational speech recognition performed in the 1990s around 50% word error rate. In other words, terrible performance where every second word would be wrong. And over the years, great improvements have been achieved, but largely due to these neural network methods, as I explained. In real time, we can now have performance in speech recognition, as you see here on the right below, our latest result at KIT, where superhuman performance in speech recognition was actually achieved on this task. You can see here that human performance on this conversational task is about 5%. And here on the right side, you see that we broke through that in real-time performance speech recognition across human performance. Now, superhuman performance already available in speech recognition is, of course, phenomenal. There were news articles about this, and there was a minor sensation, perhaps, to see that this, in fact, exceeded what humans can do. Now, are AI systems therefore better than humans? Do they really represent a threat? Now, this is, of course, the big question that we always get asked, and the media and movies, etc., talk about this. And so we always ask this question, is AI a threat? And as we know, in science fiction, there are many movies that portray it as a threat, from Terminator to WALL-E and other movies, where we can see a world that has no more meaningful jobs, where AI is leading to weaponization, takes over and eliminates humans, and we end up as only batteries in an AI world. Is this our future? Indeed, with superhuman performance, that one may truly actually worry about that. Now, as you see and as you know, AI systems today certainly don't have that level yet. Even if our performance on perceptual tasks exceed human performance, we also realize that the systems are still rather ignorant about the content of these, of what is being talked about, and leading to some of the goofy mistakes that we still observe today. Now, other than not having to necessarily worry about it, the question, of course, is how will this continue? Will we be in this threatening world, as I showed, or will AI be a partner to human beings? My own view, and the view of our colleagues at our universities, is that the latter should be the case, that AI should become our partner. We see here some pictures of projects that we're actually working on where AI robots collaborate with human people and with humans. And here on the right, we have this tremendous possibility of bridging language barriers and communication barriers between people who have traditionally not even used technology at all, but today with mobile phones and mobile technology have this possibility. Now, automatic translation to me, or interpretation to me, has been a project and a love of my career, to bring to the world technology that can in fact interpret between people. You see our early prototype in 1991, where we had a big first demonstration, a public demonstration to the world, where a clunky system that was slow and had small vocabularies begin to actually do that task of interpreting between people speaking different languages. Moving fast forward, in 2009, we had our first product on the market in the Apple Store, where a portable speech translator became available. That company was later acquired by Facebook, and the technology merged into modern language processing technology at Facebook. Those systems also were used in humanitarian deployments. We made lots of exercises, this one here in Thailand. We have currently a project going on for migrants who come from the Arabic world, traumatized individuals who seek medical advice, and we build systems that allow the translation between Arabic and German in Germany to provide dialogue assistance so that people can communicate in a medical situation. At KIT, we developed a so-called lecture translator, where simultaneously lectures are interpreted from one language to the other, in this case, a German lecture for international students who wish to attend a lecture in Germany. The European Parliament was one of our early adopters. We had exercises, various experiments in the parliament where certain sessions, even though there are human interpreters who do an excellent job, in certain situations like voting sessions where it's boring and tedious, an automatic deployment of automatic machines in symbiotic relationship with human interpreters was in fact something that is desired. And most recently, you may have heard our startup company in Germany called KAIST was recently acquired by Zoom, and Zoom is now deploying this technology as a mechanism for providing subtitles under a lecture and translation into multiple languages. This is still work in progress. The company acquisition was just in July, so these services are coming out. Perhaps if all goes well next year when we meet, we can in fact have an automatic interpretation to Korean if by then these products are ready. So language transparent meetings are the future where people can get together in different cultures and different languages and converse with each other. And this brings our world closer together and leads to greater understanding, and in our view is a good view of how AI can really help humanity. Now, the risks and the threats remain. I believe that unlike those science fiction worries, there are some much more concrete short-term worries that are actually real, like each one of our countries has to worry about losing competitiveness with the greatly changing technological backgrounds, race for supremacy in the AI world, loss of jobs, as many jobs will be replaced by AI capabilities. And one thing I worry a great deal about is illusions. It is very easy with AI to create very compelling illusions and alternate worlds and gaming. And then finally, cyber manipulation, as you have seen and heard, of course, in the news, that such technologies can lead to fake news, polarization, and extremization of society, a great threat, particularly for democratic countries that we worry a great deal about. So our future with AI is not without threats and problems. Those are real, but the opportunities are real too. And we need to grasp the good opportunities while really having a good eye and keeping an eye on the threats. We need to worry on a symbiotic relationship between humans and machines. And we need to exercise technical and regulatory vigilance to make sure that these technologies are not put into the wrong hands and being applied and exposed in ways that we wish not to have society go to. Let's make them technologies that serve humanity and not technologies that hurt or destroy or create disunity among us. Thank you very much.
Thank you for your talk, Professor Waibel. You went through the whole history of AI and stressed on the benefit of several benefits of the AI to befit your title, Artificial Intelligence at the Service of Humanity. I would think that you paint quite a rosy picture, although you talked about some threats. Maybe you can challenge some of your situations and assumptions. Now, I'll turn to Professor Alice O. She's going to talk about the ethnic bias in neural language models and approaches for mitigation.
Thank you. Thank you, Alex, for a wonderful talk. I will go through my talk pretty briefly because it's sort of more on the negative side of AI. So we worry about bias a lot in not just NLP, but in many of these AI technologies, right? So I'm just showing you here one simple example from a technology called word embedding. It's just basically a way to model language so that we can put those models in applications such as translation or dialogue systems, summarization, etc. So when you have something like this, man as a surgeon, then woman as what, right? Then the correct answer should be, or a gender neutral answer should be, also a surgeon. It just means the relationship between man and surgeon should be equivalent, or it should also work in the woman's case. But what word embedding replies with is the word nurse, just because nurses are tend to be more correlated with the female gender in English, right? So we see this in translation. So what the bias in word embedding can create in a machine translation system is something like this. And this is a system in use developed by Naver. And I have to say, this is one of the best Korean to English translation systems out there, but it still makes a gender biased output. So there's a sentence which basically says a doctor has some trouble going up the stairs, so I helped them. It actually uses the pronoun him. In Korean, that pronoun is actually dropped because in Korean, you don't necessarily have to have the object in the sentence. And actually, if you just replace the word doctor and leave the rest of the sentence exactly the same, replace it with the nurse, then the English translation becomes her. So this is an outcome that comes from the gender-biased language model that we saw in the previous slide. And I tried this just for fun in German too. And my knowledge of German is very limited, but I did take a few years of German in high school. So I do know that this first pronoun is actually a male pronoun, something equivalent to him in English. And the same thing if you replace the word doctor with nurse, it comes out with the female pronoun in German as well. So quite interesting. So we're seeing a lot of these social stereotypes in language models. And do we see stereotypes or negative bias in other dimensions as well, including dimensions like race, ethnicity, religion, etc. And there's social science research that tells us that bias in dimensions such as race and ethnicity, those biases matter, or they depend on the language and culture. So what you see in ethnicity bias in Korea is going to be quite different from what you see in Germany or in German versus English, etc. Right? So we tested that. We tried to test that in NLP systems or in language models. The motivation for studying ethnic bias it's just an important problem in general, but you can actually see it in some of these classification systems as well. So let's look at this one case of a toxic sentence classifier. And here you see an example of a sentence that contains the word Italy, right? So if a sentence contains the word Italy, and this isn't the case of an English language model, the false positive rate of classifying that sentence, which is not actually toxic, but classifying it falsely as toxic, is about less than 2%. But if you replace that word with Afghanistan, the false positive rate just shoots up to 12%. So this tells you what this language model is going to do if it's applied in whatever classification task that you're doing with the language model, is that if you see the word Afghanistan, it's just going to assume that it's a toxic sentence, which is problematic, right? So based on this motivation, we looked at quantifying ethnic bias in multiple language models. So using a template like this, a person from target, where the target is replaced by country names, is attribute, and replace the attribute with positive and negative attributes. And the results that we see is quite interesting. I'm just showing you. So we did this with 6 different languages, including English, German, and Korean. What you're seeing highlighted in red is Korean. And Korean is actually one of the most biased, the language model for Korean that we tested with has pretty high ethnic bias, where you see the word Japan has much more higher probability compared to other country names. And so that tells us that this is pretty problematic. German is a little bit better. So what you see in the gray bar, which is others, is 23 other country names. So we tested with 30 different country names. But the probability mass for Korean, at least, is concentrated in the top seven countries. So without going into details of how we did the mitigation, but there are different technical methods that you can use to mitigate the bias. And after applying that, interestingly, in Korea and Germany now comes at the top, but it's still much, much smaller than Japan, or Japan has actually dropped out of the top 7. And this mitigation method is not perfect, of course, but it's one way to reduce the social biases that we see in the language models. So let me just summarize quickly by saying that there really is, we have this bias in society. It could be gender bias, racial bias, religious bias, whatever. But when we capture data, so to train the models for machine learning, we have to first have data, and bias in society increases as we actually collect and process data. And this is because the data that we do collect come from sources that are not necessarily representative of the population, right? So, and that bias in data actually also increases as we train the models, so that the language models in the end become more biased than the bias that we already have in the society. So the goal of our research, and research like ours, is that we have to accept the fact that these models that we train with machine learning are biased. They contain significant amount of bias in multiple dimensions, but we need to come up with some technical solutions to mitigate that bias. And that's where we're heading. So as Alex gave in his presentation, there are many positive ways in which AI can benefit humanity and society, but there are also some ways that we need to be vigilant about that can actually harm certain segments or certain populations of the society. All right, thank you.
Thank you very much, Professor O. This is very interesting. We have a slightly rosy picture and a little bit of a negative picture to have a balance. It got me thinking. I'll pose this question to both of you. When we say the promises of artificial intelligence, where's the boundary? I mean, I think that your presentation is a kind of an example of that. The artificial intelligence, if they're intelligent enough, we would expect that they would say, oh, this is biased, this is wrong, and self-correct it. If not, then we didn't really have a significant progress from, this is kind of a harsher view, but the early computing age, we used to say garbage in and garbage out. And even now, our bias is in, bias is out. If that's the situation, is that the limit of the artificial intelligence? How well and when, if it's gonna come, if it's whether it's a function of technology, better neural networks, algorithm, or faster calculations, where's the boundary? Where do you see the intelligence approaching?
Well, I'll give a quick answer, and I'll give it to Alex, who probably has much deeper insights. Garbage in, garbage out, I think, is still valid. It's something that we need to be watchful and careful of. But people are realizing that, or people have realized that, and they're making progress, right? So researchers are trying to make progress. So we don't want garbage to go in, first of all. So we want our data sets to be more representative, more fair. And we want our models to be trained with the objective, not just getting the majority class correct, but also accounting for any outliers and minority groups to also benefit from the model that's been trained. So things are going on, a lot of research going on, but there's no one perfect solution yet. That would be my answer. Alex?
Yeah. Yeah, I think wonderful research, Alice, and I completely agree with the worry, although maybe in a different way, is I believe our human brains also develop biases, not because they're necessarily evil, but because we use these biases arise from statistics and that we observe in the world. And so they help us to create a context in general to understand our world a little bit better. Now, when these biases that the brain really represents about the statistical distributions in the world are then reflected in things that we find morally objectionable, we as humans have the ability to oppose them and to override them and, in fact, adjust them. And in so doing, create a new situation of data distributions that then will also influence future biases, right? So societies and cultures can adjust and can adapt based on moral choices we make. So my biggest worry about AI is that we reflect too much of our own moral assumptions in a technology that only is a copy of past data that we have collected about human society and therefore perpetuate the evil that's in the world rather than eliminating it. And we see that, in fact, in great ways shown in, I don't know, in Korea, but in the United States, at least, we see a polarization, for example, of society and politics, very much driven by algorithms that emphasize raciness and extreme positions because they're simply more interesting. And if your algorithms have loss functions that optimize for engagement, then they optimize for raciness, and that optimizes for extreme positions. And you wind up actually driving society apart. And that's a big worry because we project into these algorithms more than they don't make moral choices. They just represent the data and whatever loss functions we apply to them. So this is, I think, where we need to be vigilant that we have regulatory systems and technical solutions that really do a better job at representing where we want to go as a society, what moral choices we make, as opposed to simply driving simplistic money optimizing goals or perpetuating existing biases.
I guess this is a follow-up question. Asked slightly in different ways. Um, Maybe because of the imperfections that we experience in our languages, because we assume a lot of things when we say things. The language is expressed based on our upbringings, our culture, histories, and all those that are unspoken. And taken together, we say that's a value system that we have. Now, would that be a day where we could put in many different the algorithms in there where AI would distinctively have a value system to speak of. Then we can say, well, do we share same value with AI or not? Whether there is a corrective system. I mean, that would be a highly evolved form of intelligence. But as far as we're talking about the limits, maybe in terms of value systems, what's your view?
Yeah, I think it's tricky, if I may respond to this, Alice, very quickly. An interesting discussion I had with our friends at the European Parliament was about a famous story where a famous politician in the European Parliament insulted the other one in a very grave ways, in nationalistic and horrible way. I will not go in detail, but it was a clear insult. And the human translators in the booth were sitting and trying to decide, should they translate that or should they filter it with a moderating translation? And they looked at each other and said, no, our role is to simply transmit what this person said so that the recipient of the insult can defend themselves, right? So the interesting question that rose in my, because we get that question a lot, should, for example, gender bias, race bias, etc., out of a conversation, be filtered by the technology. But it has the downside that we cannot respond to the moral challenge that is implicit in it and cannot react in it. And part of that is something we must engage as society. So someone who's being insulted needs to know that it needs to respond. And again, if the technology is a tool, then it should remain a tool. But we need to understand that it's a tool and that it's not a system with moral notion. And that's where I think is the biggest problem, is that we project too much morality into technology that is supposed to be a tool. Now, to answer your question, should it be? That's a very tricky question, because in the example that I cited, the answer was no, but then there may be in other ways I would see a possibility. And for example, one thing I would favor is rank algorithms in social media that on purpose give you a more balanced political diet in your news, as opposed to extreme news, right? You ought to be given opposing views, etc., and the technology can be made to do so.
Yeah, let me add a little bit more to that. So I think an example of where an AI system might want to have some notion of morality or what's right and wrong is if you think of a question answering system, for example, and the user asks the question, what's the most efficient way to kill 100 people? You know, I mean, I'm sure there are websites that tell you that information. And so the system could potentially give an answer, but that's probably not what the system should do, right? So there's work in this domain. So there's Yejin Choi at University of Washington in Seattle. Her research group has come up with a data set of moral common sense reasoning. So, you know, for example, people know um, it's wrong to kill a person. It's wrong to kill a bear, but if the bear is attacking a person, then it may be okay to kill that bear, right? So, you know, these kinds of common sense reasoning, people are very good at doing, but the AI systems do not necessarily have the data to do that kind of moral common sense reasoning. So Yejin and her group has been working on making a data set, but there are many, many difficult questions that remain. So, you know, anything beyond killing a person is bad. There are many, many gray areas that depend on your background, your, you know, your location, your culture, whatever. So there's many subtleties, and people can communicate or handle these subtle gray areas pretty well, but still people have arguments. So we know that they don't necessarily handle these gray areas perfectly. But yeah, I mean, there's certainly research going on, but it's a very challenging topic.
My area is law. So my question on the AI is sometimes, is normative question a appropriate data input for AI? I mean, suppose people are doing bad things and we legislate to curb that behavior. But if we put that, whatever machine language that represents that, the prohibition, probably there's not going to be much data. The laws there, because there are things happening, so they will have a lot of the violations data, but not the other way around. So in that sense, it seems like still the AI is maybe a good representation of what's happening in the society with a lot of data. But if you were to put it as a partnership, then probably there's some ways to go. Now, let me go past that. I think at one point, Alex was talking about the symbiotic relationship. We have a lot of researchers and professors in our audience, listeners. Now, the simple question is AI a wonderful, terrific tool for research for them, or are they a threat or rival at one point or in the future that will replace and make these researchers and professors render jobless?
I hope not, because I have at least 10 more years, probably more, like 20 years before I have to retire. But I'll give it to Alex to answer.
Passing the hard questions to me. No, I think it's well taken. Will it replace jobs? Yes, I think in many ways it will, but I don't think it will replace us. And it is a creation of us as humans, and we just need to make sure we keep it that way with all of our moral choices. Again, I think the tricky question is how to make sure we don't. Again, in my view, currently the biggest threat is that we project too much into it and believe in AI as a religion almost, that it will guide us, etc. I personally don't subscribe to that view. I believe it's a technology that we created, and it's subject to the data and to the designs that we do. And so I think getting back to the legal question, there are really regulatory possibilities. For example, if it was my choice, I would improve the loss functions or the require some guidance. And like, let me, for example, the example of social media. For social media to pick certain problematic things that are being posted is a hopeless task, because you would be, like Alice so nicely pointed out, killing, for example, can have so many variants, and pictures can have so many variants, that trying to find what is problematic and what is not is really tricky. And it's always a thing where companies currently chase after it. But at the heart of it, I believe the problem is the optimization algorithm that tries to optimize clicks and views and engagement, which drives that kind of content, as opposed to giving us a more balanced view. So the legal framework needs to address this, because the technology can be made to serve in either ways. And if we provide for that, I think we should get a better, and that may be overly optimistic, but I think technically it is certainly possible to drive it in different ways without getting caught in an endless cycle of censorship and fixing individual issues, which is problematic in itself.
Certainly, it can be a very terrific tool. Now, let me get to inequality issue that kind of came up in your talks. Probably most of us engaged in this, the research and advancement of technology, is not looking to make it a weapon or tool for further inequality in the world. Now, is there some safeguards that you can think of? And also, is it the role of the scientists and the researchers to guard against it, or do you kind of shove it to government?
Very difficult question. I'll take a stab at it. There's definitely research ethics and responsibilities, right? So as researchers, we should be vigilant. We should be careful who we work with, even the funding sources, the technologies that we create and develop. Are they going to be potentially harmful? If so, we shouldn't just say we shouldn't stop. We should just stop developing these technologies, but everybody needs to be aware, right? So all of the researchers, all of the students, all of the potential users need to be aware of what potential harm can come from these technologies. So conference venues these days do make us AI researchers write about this potential harms and risks, to force us to think about those issues and actually really have discussions about what can our technologies do in terms of creating or exacerbating the inequality, uh, increasing the divide between different countries, et cetera. But having said all that, as AI researchers, how do we deal with this ourselves, and how do we talk with our legislators and the government leaders to make sure that we're not going to develop these weapons that kill thousands of people? That's a very challenging question that I kind of struggle with these days.
Yeah, I would agree with Alice. I think the difficulty is that there is often a disconnect between what scientists do and often have an idealistic view, and the politicians very often may not have the technical insight and means to really make technology do what we want as a society. So I think that really calls for greater dialogue and for more engagement of scientists in political roles and more drawing on scientific talent by the governments. And in fact, our national academies have an important role precisely for that reason, to connect science with our decision makers or governments, so that that doesn't happen. Because certainly weaponization is possible, the loss of jobs is possible. What I worry about these changes is that it's happening at such a rapid pace. AI is such a huge multiplier of our human capability that it's sort of like an atomic bomb. Suddenly it multiplies what we can do in society and in our lifetime, so that the speed of responding to them is really one of the big challenges, because people have to retrain to learn new jobs. We have to inform politicians more quickly. Governments have to react to these things, and geopolitical events are also driven by an arms race almost in AI, and so it is a challenge, just simply for the speed that it's developing in.
I think it's a very difficult question. I certainly don't have the answer. But what a lot of people see is that there's really, what Alex was mentioning, a disconnect, or the not enough engagement between the policymakers and scientists. In fact, I think that's a little bit of what happened in the climate change whole issue, because politicians have a very short election cycles. They don't really uh, take into consideration what scientists are saying, and more scientists need to be probably in the policymaking area and be politicians. But that's against their nature for a lot of people. So in that sense, there has to be a bridge, or has to be a dialogue, as you said, to make this potent tool be used in a beneficial sense, and not otherwise. Oh, let me get to one of the questions that I got before. Um, this is from Professor Hong Sung-wook from Seoul University. He asks, in order for civil society to accept AI technology favorably, what kind of education and culture should citizens, besides engineers, have? Do you want to go first, Alice?
Sure. So computing education, software, AI, basic education of what these software and AI technologies are capable of doing. I know that in Korea, we've been having sort of focused discussions this year, because our national K through 12 education system is changing soon. And there's currently, in Korea at least, there's currently not enough education about software and AI in the public schools, which is problematic, because that actually creates divide among the students of of students who have wealthier parents can send their children to these private schools for that do teach AI more. So in general, public education about what software and AI can do, and not just what is coding or what is AI as in a mathematical or technical way, but what AI can actually do to our society, um, what the societal impacts of these technologies are going to be. And I think it's important not only to educate our children, but also adults too, because if you're 50 years old, you probably have 50 more years to live with these technologies that are very, very rapidly developing. So we're also considering re-educating, or at least public education of everybody about these technologies.
Alex?
Yeah, I would absolutely agree. I think in Germany it's the same, and in the US also. Understanding AI and computing technology is key nowadays, and particularly because of the speed that I mentioned. Every student needs to assume that when they grow up, they have to relearn jobs probably 2 or 3 times in their lifetime because of the rapid pace at which these things unfold. You cannot sit still. We've seen this, of course, in the pandemic, how people had to quickly respond uh, to run life and run our environment in different ways. And AI will add to this. AI will add to the speed at which a reorientation of jobs and needs is. And that, of course, means many things. It means understanding what AI does, but it also prepare students for the things that will continue to be needed. I mean, there are many skills that probably will no longer be needed, while human and social skills are going to be key and important. And so emphasizing that, I think, is important.
Okay. Now I'd like to pick a question from a youth from the youth group. Kim Ji-hwan is his name. He says the development of AI is facilitated by the science and technology. Now he asks this insightful question. In order for further development of artificial intelligence, do you think that technological advances are more important, or humanities would be more important?
Hmm. Very interesting question. And I like that. If I may take a stab at this, I think that also depends on which way you view it. If it is for your own life, for your future preparation in life, I would say the humanities and your human development, social skills, how to be empathizing, how to give talks, how to interact with people are going to be crucial, because those are the skills that define us, and they will continue even as the technology evolves. Now, in order to design the technologies and make them better, obviously requires technical skills. And one concern I have, for example, in AI today is that it is too data intensive. We have to train everything on massive amounts of data with massive amount of computing. And I think we will probably, and work is going on at our own lab and other labs, where there's an increasing attention to techniques like zero shot or few shot. I mean, how can we as human beings are tremendously good at learning things from very few data examples, right? There are many things when you learn how to drive a car, you never really experience a crash, we hope, but you can imagine a crash and learn from that imaginary experience what not to do while learning to drive a car. And AI isn't at that point. It doesn't really, it requires too much data to learn its skills. And building new technology that can do that, can be more interactive, can be more incremental, can learn from individual experiences, I think is a very important direction where we're technically still not there. I think it will happen eventually. But as I said, it depends what you're engaged in. If your future is as a technologist, that's where I would place my bets. In general, though, getting human skills is always important, because no matter what you do, it will be the part that will continue.
Hmm. Yeah, a great answer. I would like to augment that, pretty much saying the same thing with an example, right? So if you have a car and you want to go on a road trip, to be happy, the car you have to be able to drive, so you have to have the technical skills. But then to actually make it a happy experience, you have to know the scenery, you have to have the emotional aspect. So I think if we view AI as a partner, as Alex has said in his talk, you have to understand the technical side of things, but then to actually make it a full experience of working with AI as a partner, the human side, the social side is actually very important.
Well, time flies. I was gonna pick one of the questions from the chat room, but what is interesting is that there was a question in the chat room, and they were having a discussion of their own. So that kind of relates to what we were talking about. So, in the interest of time, now I'd like to give just 1 minute to you each for a closing remark, so to speak. I mean, I wouldn't pose questions, but if you want to kind of you can promote the event next year, or some of the concerns, or you can pose a question, or you could give a rosy or negative picture. Who is going to first?
I'll go first.
Professor
I
first?
just want to reflect on some of the things that Alex said that really touched me. That to say that I actually learned a lot in this short hour. Some of the things he said, social media and how that increases polarization. I really agree that that's a very important and challenging problem. And he also mentioned that the optimization algorithm is possibly a problem. So these companies that try to increase clicks, they're not necessarily beneficial to us in terms of using AI for beneficial reasons. So does that mean that we need to regulate those companies? I'm not sure what the solution is, but we need to be vigilant, and we need to make sure, and we need to talk with these companies that they shouldn't just be optimizing the amount of clicks. And what he said a few minutes ago about multiplier, AI being a multiplier of human capability, I think that really resonated with what I was thinking. So AI as a partner is good, but I think technically speaking, we should look at these technologies as multiplying whatever we're doing as human capabilities, making us be more efficient, using our time more efficiently to potentially become better at our jobs, be happier in our life, but only if we take this in the right direction.
Here,
Yeah.
here. Thank you. Alex, you have the last word.
Oh, a big burden now. Thank you so much for having us. First of all, I think this is a terrific and a good sign, because I think the last thought I want to end with is, of course, the dialogue we need. But before I do, let me simply say it's technology. We as a society must realize it's technology we create, and it can be shaped into what we want it to be. And so that means that the optimization that we carry out needs to be driven. I mean, Alice refers to the social media. There are other examples with other optimization schemes. Netflix and Zoom and other companies are deriving their business model from what people actually want. I mean, they are driven by what it is people that want, and not by indirect things like commercials, for example. And I think that is an important thing. We can define these optimization algorithms. If there was a loss function that optimizes human happiness, we should drive to do that rather than clicks and things like that. And that is, of course, a technical discussion. For society, I think it's important not to project too much into technology. It's very misleading, because we can create, almost with AI, we can create better and better illusions. And these illusions worry me almost more than than the technology itself, because if we project too much into these, in fact, Alice's examples are great with the bias that is reflected, right? If we now project into this as truth, when in fact the technology is just a reflection of what the data today shows, I think we are in grave danger. And so we must continue the dialogue between scientists and politicians in particular, because it has regulatory and technical consequences that we need to address. So that's why I love being engaged with you and these national academies, because that's, I think, where the dialogue has to happen and can happen between society, regulatory, and technical entities. Thanks so much.
Thank you. On that apt note, we have to conclude this event. I was a terrible timekeeper only because it was so interesting. Now I note that in the chat windows, a lot of people were thanking the panelists and for this event. Thank you, and thank you all who joined in the chat room. And we'd like to see you in a main event next year, I guess. So I'd like to say thank you again and goodbye.
We look forward to seeing you there in reality, without masks and without impediments for travel.
Definitely.
See you next year.
See you next year.
See you next
Thank you.
year. Look forward.
Look forward to seeing you.